Welcome everyone. Today we would be talking about method to solve exact equations. So to begin with how to solve the exact equations, first we must know what are exact differential equations. Now differential equations of first order that would be solved with the exact order first need to satisfy certain conditions. Now what are the conditions? So the first condition, or actually the only condition for it to satisfy that, is to fulfill this condition. Now the condition states that partial derivative of m with respect to y must be equal to partial derivative of n with respect to x. Now what is this m and what is this x? We would be talking about them in further process when we will look about the differential equation. Well, to make it more easier, I have colored it. So now you can see the conditions in pink and what is the condition in yellow. So let's talk about how to solve it. Well, to solve a differential equation, you would be given a certain equation which you would break into m and n parts. Now we would be talking about how to break them, but first you know how to go with solving the exact equation. So you need to know that there are three steps involved. Now what can be those three steps? Well, they are: number one, integrate m with respect to x keeping y constant. Now you probably would be thinking what is m and what is n, but trust me, you would know it pretty soon. So we would first be integrating m with respect to x keeping y constant. Secondly, we would be integrating y we would be integrating only those values of n which do not contain x with respect to y. Now furthermore, we would be going to the third step, that is for the result when we would be comparing one, that is step number 1 plus step number 2, that would actually give us a constant value. Now let's see how to solve the question. So let's consider a question, say for example this equation. Now it states that, now what you could see actually is a part of it which is going to be multiplied with derivative of x, and a part of it that you could see on the right hand side, that is sin x square minus x square plus 3, which would be the product of dy, that is differentiate by y. Now the constant is 0, so let's go. The first step is to break down it into m and n. So how would we be breaking them into m and n? So remember that the part that is actually being multiplied by the derivative of x should be considered as m, and the part that is being multiplied by the derivative of y should be considered as n, like this. Now how would we break them? Well, we would be breaking them like this. Yes, the whole inner part would be considered as m, and it would be multiplied with dx, and the whole inner part of the second, that is right hand side, would be considered n and would be multiplied by derivative of y. Now how would we solve it? Well, to solve it we must go further. Now you can see over here, what I have done over here is that I took the part m and I just derivate it with respect to y. Now you would be probably guessing that it would actually be multiplied by derivative of x, but no, remember our first step, that was to derivate m with respect to y. So what we done over here is we have derivated the part m with respect to y, and we got an answer, that is 2x cos x square minus 2x. Now further moving forward, we have derivated n with respect to y, but keep in mind that we are not going to apply that only part that actually stated that only derivate those parts of n that does not contain x with respect to y, something like that. Now what we have done over here, we have derivated it with respect to x. Similarly, we have derivative m with respect to y. Now Our equation was m into dx plus n into dy is equals to 0, but you could see we have done equally opposite stuff. We have derivated m with respect to y and derivated. Now how to solve it? Now we already know that the both of that the condition has already been satisfied and our equation is an exact equation. Now how would we actually derive the exact equation? So let's continue with it. So the first thing you actually need to know is that how are we going to solve that. So you remember the third step, it said remember the steps, it said integrate m with respect to x and integrate n only those terms of n that does not contain x with respect to y, and then we actually combined it all together and we had a constant. So you can see over here that I've written below the m multiplied by dx equation that y as constant, and I have mentioned in the second term that n not containing x terms should only be derivated with y. So let's continue forward. So what I've done is I've taken the equation of m and n. Now you can see n only terms of n that does not contain the variable x. Continuing forward, we actually take y constant, we derive it. Oh sorry, I was trying not to make a mistake, but it happens. So this is the actual step which I was talking about. Now at the corner of the screen it is actually written c, which I am not able to actually show you right now because I do not have a tripod stand and my mobile is actually hanging from a fan, but still I think it would work. So yeah, that's right. But we see we have taken y constant and we are now going to use yes, we are now going to let x square is equals to t. Further derivating it, we would have a value that will be equal to 2x into dx would be dt. So what we actually do, we would replace 2x into dx with dt at every place, which would give us an equation something like this. Now we have this actually very sorted out equation. What we do over here, well, after we have a very simplified form, we actually put x square back where we have in the places where we have t. Further solving it, we actually have this type of equation that states y sine x square minus y x square plus x plus 3y is equals to z. Now you can remember what the question was. It was a very lengthy question which had an m part and an n part.